Project Invincible was a totally unique challenge for us as a design team. We've never as a team embarked upon something so unique, something personal and designed for an individual to such detail. The main purpose or the main challenge for Project Invincible was to develop a product or a garment that protected the thorax region of the body. In other words, doing the job of the rib cage, protecting the vital organs of the body, specifically the heart and the lungs. The main thing that they were concerned about was being able to go about their day-to-day. And we wanted to do this because we know that our client had impaired function, particularly around the fourth ribs on the left and right hand side, and impaired structural integrity of the sternum. As a team, we quickly came to an overriding design and engineering principle for the garment, and that was to do three things. We want to protect from initial impacts, transfer the load away from the region that needs the most protection, and then attenuate that load such that that force is dissipated. So the final design is a rigid composite shield structure with 3 non-Newtonian gel pads which adhere directly to the bespoke base layer using a Velcro interface.
Body scan data was used to achieve the comfortable fit when defining the overall shape of the shield. The outer surface design was based on strain analysis, reinforcing the shield only where needed, keeping the weight to the minimum. On garment design, the textiles used create a push and pull effect, where the natural fibers in the material absorb the sweat and the artificial fibers spread the sweat, improving evaporation, keeping the body cool in a tight-fit design. Using high-strength and low-profile Velcro, the shield can be easily attached in position in a discreet and low profile that can be worn under a shirt. A shield-to-body tension mechanism was developed to maintain perfect alignment during use.
The composite shield is manufactured with 3 different types of fibers, held together by a highly toughened resin system. Firstly, we have stiff carbon fibers providing the flexural rigidity and strength. Secondly, ductile Dyneema fibers, which are used in high-performance yacht sails and bulletproof vests as outer layer damage containment and central lightweight core plies. And thirdly, Xylon fibers to provide penetration resistance and energy absorption. Xylon fibers are used by all F1 teams to protect the driver in the event of a side impact. This results in a system that is highly effective in energy absorption and impact attenuation. Coupling these material systems with detailed finite element analysis, we were able to optimize both the shield and the pads to arrive at a highly effective and lightweight solution.
To inform the design of the shield, we predicted a series of impact events that the shield was likely to be exposed to. These were based on insight into the client's lifestyle wishes, as well as the design standards of motorbike armour. These impact events were then used as the basis for the design and optimisation of the system. Prototypes of the shield were put through a demanding test programme to assess their performance. This testing was carried out at the same facility that's used for the crash testing of Formula 1 chassis. A drop tower was used to apply a variety of impacts to the shield. A number of these tests were run, but as an example, one of them was the equivalent of dropping a bowling ball onto your foot from waist height, which the shield successfully passed.
At McLaren Applied Technologies, we're in the business of developing personalised medical solutions for individual patients, and Project Invincible describes a way in which we can develop a novel solution to a complex medical problem. The health business at McLaren Applied Technologies is the most embryonic, but one in which we see the greatest growth for the future.